Hi dear students, I hope you like my channel and like my videos. If you really like my videos and my channel, please press the subscribe button and the bell icon for latest notifications of videos. So let's start our new chapter, chapter number 6, that is applications of derivatives for class 12th. So see what is very first topic, rate of change of quantities. What is meaning of rate of change of quantities? Means how they change with respect to some other value. Means according to some other values change, what is the effect of that change on the related value. So we see what we have. Here you marked so many times dy upon dx. What is meaning of this? Its meaning is how y changes with respect to x. Means what are the changes in y when you change x here. So you are writing dy over dx. So its meaning is y changes with respect to x. So its meaning is rate of change of y with respect to x. When we write d over dx of y, it is called rate of change of. It is called rate of change of y with respect to x. The meaning is same. You marked okay dy over dx so many times. If I write ds over dt, what is s? S is distance. And what is time? That is t. So here we can say rate of change of distance with respect to time. You know, as time changes, we directly see effect on distance covered. So we have ds over dt's meaning as rate of change of distance with respect to time. Then in addition, you will see some use of values. Means if we have rate of change of y with respect to x, there may be some kind of calculation for which you have to find this rate of change at a particular value of x. So when you solve, you have to put that value of x in your calculations and you will get some answers. Means for example, if we have x equal to 2, you want to find rate of change of y with respect to x at x equal to 2. First of all, you have to solve that dy over dx for your x equal to 2. Means first of all you will get answer of dy over dx, then in that answer replace x by 2. Then you will get exactly the answer which is required in this case at x equal to 2. What is the rate of change of y with respect to x? Same as here, there may be some value of time. For example, it is 2 minutes. So you have to solve first for ds over dt. Then in that answer replace t by 2 and you will get some kind of answer, that is our rate of change of distance with respect to time at time 2 minutes. So in this way you will see some use of this kind of rate of change of quantities. Let's start our exercise 6.1 given in class 12th. Here is our question number 1. Find the rate of change of area of a circle. Very first thing, you have to find rate of change of area of circle. What is area of circle? Very easy for you, that is pi r square. Then you have to find rate of change of area of circle with respect to its radius r. And when given r is 3 in first part 3 centimeter and in second part r is equal to 4 centimeter. Let's start its calculation. So I am going to write first area of circle. What is area of circle? That is called, suppose okay, in this case it is a. It is pi r square. What is r? R is where r is radius of circle. Then you want to find rate of change of area with respect to radius. So you will write differentiating with respect to radius. Differentiating with respect to radius r. Then it will be dA upon dr. It will be differentiate pi r square with respect to r, means I am writing once d over dr of pi r square, which will give 2 pi r. So this is rate of change of area with respect to radius. A part is if r equal to 3 centimeter, Then what is rate of change of area with respect to radius? So dA over dr at r equal to 3 centimeter. It will be, use this 2 pi r. 2 pi r means 3 centimeters, or just write 3, and units. What will be unit of this calculation? Units of area, that is centimeter square, and you are differentiating with respect to r. R is in centimeters, so its units will be centimeter square per centimeters. So it will give 6 pi centimeter square per centimeter. Areas, rate of change given here. Okay, now part B, dA over dr at r equal to 4 centimeters. It will be, replace r by 4 here, 2 pi 4 in place of r, centimeter square, unit of area, and with respect to r we are writing so per centimeter. It will be 8 pi centimeter square per centimeter. Students, here one more thing which you have to remember, that is marking of these proper units of your required answer. So let's see what is given here in question number 2 after this. Question number 2 is, the volume of a cube is increasing at the rate of 8 centimeter cube per second. Volume of cube. Do you know what is volume of cube? That is side cube, means side raised to power 3. Then it is changing at the rate of 8 centimeter cube per second. Per second means with respect to time. Then how fast is the surface area increasing? Surface area of cube. Students, remember, if only surface area given, that means total surface area. Especially mentioned it is lateral surface area, then you have to use lateral surface area. Then what is surface area's formula for this? What is volume's formula for a cube? Volume means side cube, and surface area 6 into side square. So you have to find rate of change of its surface area when the length of an edge is 12 centimeter. Means if side is equal to 12 centimeter. So let's start its calculation. So I'm writing its answer now. Let V be the volume of a cube having side equal to x centimeter. Suppose its side is x centimeter. So therefore volume equal to, yes, it is side cube, means x cube centimeter, cube along with it. Now given to you, okay, one thing is given, rate of change of volume with respect to time. It is given 8 centimeter cube per second. Now we will differentiate with respect to t. This formula which is given, differentiating with respect to t means time, equation number 1. So write dv over dt equal to, this 3 will come in front, 3 into power will decrease by 1 means 3x square, but don't forget to write, along with it you have to differentiate this quantity which is x with respect to time. Now dv over dt given, it is 8 centimeter cube per second, and here you have 3 into x square. What is x? Edges. What is edge given? 12 centimeters. So I will use 12 square into dx over dt. Now we have to solve this and we will get an answer of this. So dx over dt will be 8 into, what about this? It will go in the denominator. So I am writing it 3 into 12 square 144. This is the value dx over dt, which is x in centimeter, t in second. So it is centimeter per second. Now if it is possible to cancel, we will cancel. 8 into 1 8, 1 8, 6 left. 8 will give 64. So it is 1 over 54 centimeter per second. This is dx over dt. It is useful in our next calculation. We have this. Now we have to find rate of change of area, which is surface area. Let S be the surface area. Then surface area's formula S 6 into side square centimeter square. Now we have to write rate of change of surface area with respect to time. So therefore ds over dt, it will be 12x centimeter square per second, or just write as we marked earlier. Okay. Now this ds over dt at x equal to 12, what will be the answer? But one thing is missing. What is the missing value? When we derivative, where is dx over dt? That we forgot to mark. So we have to write dx over dt along with it. Now we have to fill values here. 12 as it is, and x is also 12. So I am writing ds over dt at x equal to 12 centimeter. So it is 12. Where is dx over dt? It is given here 1 over 54. And since it is area centimeter square, with respect to time we are writing, then write per centimeter. Now only calculation left. 12 into 12 over 54 centimeter square per second. If cancellation possible, we will cancel. Okay. So it will go on table of 3. 3 into 18, 54, 3 into 4, 12. Then 2 into 2, 4, 2 into 9. Then 3, 3 into 3, 9, 3 into 4, 12. So we have 8 over 3 centimeter square per second. This was question number 2. Let's see what is given in third question of this. Statement of question number 3 is, the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Students, here I want to make clear one thing. If it is given increasing, then in front of this value given, we will take positive sign. But if it is given decreasing, then it will be with negative sign. So take care of these things. The radius of circle. Where is the radius of circle? Let's write its radius. Let R be the radius of circle, and it is increasing at the rate of 3 centimeter per second. Then they have given, find the rate at which the area of circle is increasing. Where is the area of circle? So we will write here let R be the radius of circle and capital A be its area. So what is given? Rate of change of radius with respect to time given. Increasing means only 3 centimeter per second. Then you have to find rate of change of area when radius is 10 centimeter. So we will write now area of circle pi r square. Therefore, what is derivative with respect to t means we will differentiate with respect to t, because we have to find rate of change of area with respect to time. So what is dA over dt? It will be 2 pi r, but don't forget to differentiate radius with respect to time also, means dr over dt. Now only we have to find answer. dA over dt at radius means r 10 centimeter. It will be 2 pi r 10 dr over dt, its value given 3, and in the end no need to worry about units. See units of area always in centimeter square or meter square. Here you have centimeter square. Time with respect to time means right per second. So it will be 60 pi centimeter square per second. So this was our third question. Here is question number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. What do you mean by edge? Edge means length of the side. Is increasing means there will be positive sign at the rate of 3 centimeter per second. So let's start by writing it. Let x be, or x centimeter be the edge of cube. Then what is given? How fast is the volume of the cube? What is the volume? And V be its volume. So we have to find how fast is the volume of cube increasing when the edge is 10 centimeter long, means length of side is 10 centimeter or x is equal to 10. Let's start calculation. So given is rate of change of length of the side with respect to, see, time given, s means time. So 3 centimeter per second. And what about volume? Volume of cube? It is side cube or x cube centimeter cube. Now write derivative with respect to time means dv over dt, or derivative of x cube with respect to time 3x square along with dx over dt. And since it is volume, so it will be volumes in centimeter cube, and with respect to time means per second. Now we have to find rate of change of volume with respect to time at x equal to 10 centimeter. So find answer, replace x by 10 and dx by dt by using its value, that is 3, and in the end centimeter cube per second. So solve it. It is 900 centimeter cube per second. This was our question number 4. See what is given next. Here is our question number 5, which is another new type of question, that is a stone is dropped into quiet lake. When still water is there, if you throw a stone there, what will you see? You will see water waves moving in circular motion, and they move in the form of circles outwards. They have given a stone is dropped into quiet lake and the waves move in circles at the speed of 5 centimeter per second. What do you mean by moving at the speed of 5 centimeter per second? Means they are moving away from that place where you dropped the stone. Suppose that stone you dropped here, they move away, means their length of this gap in this circle and the position where you throw stone increases, means they are going away. But what is this? This is radius of that circle which is changing with respect to time. They are given at the speed of 5 centimeter per second, means you have dr over dt, which is given 5 centimeter per second. At the instant when the radius of circular wave is 8 centimeter, means if r is equal to 8, how fast is the enclosed area increasing? What is area of circle? You know, pi r square. Let's start our calculation. Let area of the circle is a. So we will start now. Let r be the radius and capital A be the area. So what is given? Given is rate of change of radius with respect to time 5 centimeter per second. Area of circle is pi r square. So differentiate with respect to time. So dA over dt. It will be area pi r square. When you differentiate, it will give 2 pi r into dr over dt. And you have r given. R is 8. So we will write therefore dA over dt with respect to, okay, t we are writing at radius 8 centimeters. It will be 2 pi into 8. And what is dr over dt? It is given 5. And since this is a calculation of area, so sorry, I am writing here 8 2 times dA over dt. So it will be area's formula centimeter square, and with respect to time means per second, or 80 pi centimeter square per second. So this was question number 5. See next what is given in question number 6 after this. Sixth question is very simple. See what is given. The radius of circle is increasing at the rate of 0.7 centimeter per second. What is the rate of increase of its circumference? So there are two things. Radius, let r be the radius. R be the radius of circle. And what about circumference? And capital C be its circumference. So what is given? Here we have rate of increase of radius 0.7. So what is given? dr over time given C, per second given, dr over dt 0.7 centimeter per second. What about circumference of circle? Circumference of a circle is 2 pi r. What about its derivative with respect to time? So dc over dt, it will be 2 pi. Don't forget this radius. It will be dr over dt. Now, what is the value of this dr over dt? It is given here. So we will write therefore dc over dt. They have given what is the rate of increase of its circumference. So dc over dt will be 2 pi into 0.7 centimeter per second, but circumference is in centimeters, so same unit per second for the time. So it will be 1.4 pi centimeter per second. So this was our question number 6.